All right, let's get started. In today's session, we'll begin by delving into the fundamental aspects of DAX, exploring its purpose and significance, and then we will uncover the detailed mechanisms that make the DAX engine a powerful tool. Okay, if time permits, we will further discuss about the operators, the operators such as arithmetic operators, the logical operator, data types, and DAX. Okay, what is DAX? DAX stands for data analytics expression. The DAX is not only used in Power BI, and it is used in Excel, SSAS, Tabular, and Azure Analytics Services. And you can use DAX to apply a filter, or you can query a physical table. And also, the DAX, using DAX function, you can create a virtual table. For example, if you want to store the subset of the table data into separate table, you can use DAX functions to create a virtual table. And also, if you want to clone an existing physical table, that is also possible with a couple of few DAX functions. Okay. Now the question is why to use DAX. We already discussed because of the audio issues. I'm going to repeat it again. So once you create a DAX, you can reuse it. Okay. So we can reuse it. That is one advantage of using DAX. For example, you want to compute the total sales. So here you have the total sales. Look here, if you look at this formula here, right? So total sales equal sign. On the right side of the equal sign, you can find the sum of financial sales. So once you compute the total sales, and then using the sum function, sum is a DAX function, you can store it in a variable called total sales. This variable is your this one, the measure. Okay, this is called your measure. Okay, so once you create a measure, or once you have this formula, DAX formula available in place, you can reuse it wherever you need it. Okay, and also to create a complex or customized formulas, all the time the sum or average functions are not sufficient. Obviously, you may have to implement certain complex logics. So for that, you can use different types of functions that are available as part of DAX itself. Okay, as part of DAX. So where are the DAX formulas are used in Power BI? We have something called calculated tables and calculated columns, and then measures. Okay, and measures. So these are the three things are fundamental to your DAX. You should be knowing this one. Okay. Next one is what is the difference between DAX and M language? M language, you can use it, that is used only in Power Query Editor, whereas the DAX is used separately. You cannot use both in the same place. Okay. For example, in Power Query Editor, you cannot use DAX. Okay, and M is a query language. It is used in Power Query Editor. So DAX is an analytical function, right? So the analytical data calculation language. So these two are, like I said, the M language and DAX are not dependent upon each other. Okay. These two are mutually exclusive. And importantly, you should be knowing the internal mechanisms of the DAX engines. Once you create a DAX query, and then if you, let's say you have created a DAX query in a measure, the moment when you drag and drop the measure into a visual, so what is happening? What are the internal, mechanisms? We need to understand that one, okay? Because only when you understand this one, you should be able to do the query tuning, DAX query tuning, everything, okay? The DAX engine, it comprises of two different engines, the DAX queries, okay? The formula engine and the storage engine. These two engines work together to compress your data and encode your raw data and access DAX queries. Okay, sorry. Okay, now the question is, what is this formula engine and storage engine? This formula engine is responsible for accepting your DAX query. For example, this is what your DAX query. Total revenue in Chicago, equal sign. The right side of the equal sign you have used the DAX function called calculate. Calculate is an important function in DAX. Even in the interview, they'll ask you, and you should tell them, if they ask you what are the DAX function that you have used, you need to tell them that you've used calculate. That is what they expect, because it is the fundamental thing. And it is a very robust function. Okay. So this is the thing, calculate and sale. So it's something like sum of sale. And here we want to understand in Chicago, what is the total sales we made? Okay, that is what your total revenue in Chicago. Once you create this in a measure, so what has happening is, the moment when you drag and drop this measure into visual, the DAX request will be sent behind the scene to your formula engine. Okay, so the formula engine, what it does is, it processes the request, and then it accepts the request. It generates a query plan. Which one? The formula engine. Once it generates the query plan, it sends the query plan to your storage engine. Why it has to send the query plan to storage engine? Because the formula engine cannot access the data directly. He cannot access this data directly. He has to access the data via storage engine only. In order to access the data via storage engine, you need to submit the query plan to the storage engine. Okay, the formula engine sends a data request to your storage engine, because the formula engine cannot access or retrieve the data directly from your source data set. Okay, so upon receiving the query plan, the storage engine returns the XVelocity or VertiPack data cache. See, he cannot access the data directly. Who? The formula engine. Hence, he has to send a query plan to this guy, and he has to go and fetch the data as per the query plan, and then return the data back to your formula engine. Okay, this is happening in the case of import mode. This is applicable in the case of import mode. For example, yeah, this is happening in, okay, I'll just write it here, import mode. In import mode, this is what is happening. Whereas in the case of direct connection mode, the formula engine is the one sends the SQL query directly to your SSMS or the database. Okay, it sends the query to your database directly. In the case of direct query, you look at direct query, the formula engine sends the SQL query directly to your source database. Okay, and once the query gets executed, the output of the query will be sent back to your formula engine. So this is the difference between the import and direct query mode when it comes to the internal mechanisms, or under the hood, this is what is happening. Okay, in the case of import, it has to send the query plan to your storage engine, and then the VertiPack. Previously, the XVelocity was called as a VertiPack, and currently we call the VertiPack as, they renamed the VertiPack as XVelocity. That's all, not much difference. So what XVelocity does is, it carries out 3 tasks. Okay, upon receiving the query plan from the formula engine, it carries out 3 tasks or three actions. So one is it compresses the data. Sorry, it converts your table or data to columnar data. Converts which one? The XVelocity engine converts your table or data into columnar data, step 1. And in the second step, what it does is compresses the data. And then third step is it load the data in memory. Load the data in memory. It's kind of a zipping the file and then load the zipped file in memory. So the reason why it compresses the data is obviously when you compress the data, the size of, it doesn't require too much of storage. And once you compress the data and if you load the data in memory, it doesn't require too much of memory space, right? In memory, it doesn't require too much. It doesn't require the bigger memory size. But what is this? Why it has to convert the tabular into columnar? I discussed yesterday, but I'll repeat it. So nowadays the columnar database are very popular in the case of analytics and all. Okay, because if the columns are stored separately in the case of columnar database, whereas in the case of a tabular database, the data are stored row based. Hence, the performance is very, very slow in the case of row based. For example, especially in the case of more number of columns you have in your data set, and at the same time, the volume of the data is very huge. That kind of situation, it will be literally slow when you use the row-based database. So that is the reason why it converts the tabular data into columnar structure, and then it encodes the data and compresses the data within each of the columns. So these are the 3 steps, but in the case of direct query, the XVelocity will not, the XVelocity engine is not at all coming into picture. The query plan will be sent directly to a SQL server. The query will get executed, the output of the data. But whereas in the case of import mode, these 3 steps are carried out behind the scene automatically. Okay, we don't have to write any program to do this one, or we don't have to do it manually. And now the question is, okay, what is columnar database? Anybody? Can someone give me an example for columnar database? How many of you are familiar with Hadoop? Columnar data, Apache Cassandra and HBase. So these are HBase and Vertica. How many of you are familiar with Vertica? I guess Vertica is HP's product, right? Vertica and Cassandra. And you have HBase. Facebook is using HBase to give you the DynamoDB. Very good, Pooja. Okay, DynamoDB and MarkLogic SQL. You have something called MarkLogic SQL. These are kind of NoSQL database. Okay, NoSQL database, and it's a columnar oriented. Okay. In the case of columnar database, a single column access is pretty faster and effective. Okay, and simply said, if you have to say simply, right, the columnar database are more CPU exhaustive, whereas the row store database increases IO because of many scans of useless data. See, in the case of row store, what is happening? This is what is happening. If you have, let's say you have 100 columns, 100 columns are there in your data set. Out of the 100 columns, for your report, you just need 4 columns only. 4 columns only. So in that case, what happens is in the case of row store, it goes and checks, hey, I need the name column. Is that a name? No. It keeps skip the columns until it finds the name and unit price. Let's say you wanted to select only these 2 columns. And in the case of row store, especially the huge volume of the data, number of columns or more, it has to go and check the each and every column. It has to scan each and every column until it finds the desired columns. In that case, it takes more time. Hence, what they did, they came up with something called column store. And that is also the reason why the column store databases are gaining a lot of popularity. In this case, each columns were stored separately. Okay. But don't ask me, okay, if I want to access, out of 100 columns, 50 columns, it has to go and, read the data from each and everything, right? Yes, it has to. If the number of columns are more for your report, right, in that case, it will be very CPU intensive. For example, you are just taking the subset of, the subset of the columns, right? Only few subset of the columns in a row store. In that kind of situation, the columnar database is very effective. It goes directly to the columns instead of going and checking each and every column. Since you are storing the data separately for each column, it goes to the respect to the column directly. It doesn't involve any IO here. Okay, it doesn't involve any IO, but whereas here it involves some kind of CPU. It's kind of a CPU intensive, especially the number of columns that you want to read it or more. Okay, so in this case, usually in the case of analytics, we don't use so many columns from your data set. Okay, so in that kind of situation, it goes, for example, if you want to retrieve the name and the corresponding unit price for camcorder and smartphone alone. So, right, so since you store the columns separately, the performance is pretty faster. Now we understood what is the difference between the row store and column store. In the case of column store, the data gets stored separately in each and every column. Okay, hence there is no need to scan each and every column like in the case of row store. It goes directly to the respective column and then it retrieves the data. Whereas here it goes and scans each and every column. It takes longer time. Okay. Next one is the second step we discussed. In the VertiPack, what it does is, or the XVelocity. The recent name is XVelocity engine. The XVelocity engine, it converts your tabular data into columnar, and then the second step is it compresses your data. It uses some compression algorithm or technique to and it uses some kind of compression algorithm or technique, and then it encodes the data to reduce the amount of memory required to process your query. So basically, the compression, right? It involves some kind of technique, and then right, it stores a compressed copy of the database in memory. So what are the types? What are the techniques it uses to compress the data? Right. So the technique which uses it to compress data is called encoding in DAX. The objective of this one is to reduce the amount of memory required to process your query. It's as simple as that. Okay, there is something called value encoding. There are three types of compression techniques. One is the value encoding. Other one is run length encoding. And we have something else called hash encoding. Okay, we'll start with understand what is value encoding. So let's say your columns in your data set, whatever the columns that you want to use it are integers, right? So in that case, value encoding is done. Your XVelocity engine, which is nothing but the VertiPack, it converts a lot of values in Power BI to integers. Okay. Dictionary encoding is used on text values. Okay, I have an integer data type, then value encoding is done. In the case of text, dictionary encoding is done. If you have repeated values in a column, that kind of RLE, run length encoding. Okay, these are the three types of compression techniques are available. Integer, value encoding. For text, it does the dictionary encoding, and then the repeating values uses something called run length encoding. Okay. So what is value encoding? That is what I said. Value, in the case of value encoding, it is value encoding is applied on the integer columns. Okay, because VertiPack converts a lot of values in Power BI to integers. So value encoding is used on integer values. This is the important point. Remember this. Okay, this is the data set. Fine. This is the data points given to you. And in this data point, what happens is it finds out the maximum value, 216. Am I correct? In this data set, the maximum value is 216. It subtracts the maximum value from each and every value. For example, 212 minus 216. Okay, sorry, the maximum and minimum value. Okay. So here maximum is 216, and here there is 194. Look here, 194. The minimum value. Sorry, the minimum value. Okay, it takes into account of the minimum value. So 194. So 212 minus 194. How much? 18. Right. So 197 minus 194, 3. 214 minus 194 20, and 197 minus 194 3, and 214 197 minus 194 is 3, 194 minus 194 is 0. So it picks up the minimum value, and then it subtracts the minimum value from each and every value. So this is your encoded value. This is our original data. In the case of value encoding, what happens is it finds out the minimum value. It subtracts the minimum value from each and every value. So that is how it transforms the original data into value encoded data set. Okay. So here, what is the difference here? So here the maximum value is 216. In this case, it requires 8 bits to store the data. Whereas here, what is the maximum value? 22. Only 5 bits are required here. Okay. Storing numbers up to 22 requires less bits than storing numbers up to 216. It's pretty common sense, right? Storing numbers up to 22, it requires only less bits than storing the values up to 216. Okay, you might be wondering, so in this case, what is the storage space saved? Here 8 bits required, here 5 bits are required. Okay, but the difference is just 3 bits only. This might seem a very small value in terms of saving the storage. But if you have huge volume of the data, let's say you have billions of records, right? So let's say you have 100 billion records or 50 billion records. 50 into 5 bits, how much? It's a big number, right? So okay. So this is how the value encoding technique is applied on your integer column. It reduces the number of bits needed, value encoding. Okay, that is the whole idea of using value encoding. It works with the integer column, remember that. The next one is the hash encoding. What is hash encoding? Anybody knows the hash encoding? Hash encoding is used in C, the other language, right? C language and all. What is, hashing, okay. What is hash encoding, right? Hash encoding is used on text value. Supposing your text column, if it is a numeric column, it uses your integer column value. This one, the value encoding is done to compress the data. Whereas if the text data is there, the hash encoding, there is something called hash encoding. That is the technique is used. So supposing you have your original data is something like this. You have a column called color and different colors are there. So what happens in this case, it builds a dictionary, something like this. It builds a dictionary, something like this, and then it finds out the distinct value from this column. What are the unique values? Okay. So red is appearing multiple times. Hence, we don't have to consider the duplicate values. Just take the unique value, red, white, and black, and blue. That's all right. Only 4 values are the unique values. These unique values are stored in a memory, okay, and then it assigns the integer value for the index. It assigns the integer value for the index. Okay, the index values are sequential, 0, 1, 2, 3. Here what happens is, if you look at here, wherever red is there, the red was replaced by 0. The red was replaced by 0, whereas the white was replaced by 1, and black. Instead of storing the text like this, if you store 0, 1, 2, 3, it saves a lot of space. So behind the scene, the XVelocity engine, it builds a dictionary something like this. It contains the distinct values of your column. It replaces the column values by what? With the integer values, integer numbers. Here, each number is the dictionary index of the original value. So if the cardinality is lower, the smaller the number of bits are required to store a single value. Okay. See, in this case, what is cardinality? Cardinality is nothing but distinct values, unique values. Distinct or cardinality. This cardinality term is different. You remember when I say cardinality, definitely it comes to your mind the relationship. In data modeling, we discussed about relationship, right? The cardinality types, one to one, one to many, many to one, many to many. But when it comes to the columns, even in the case of columns, we use a term called cardinality. Cardinality is nothing but the distinct value. The lesser the, the unique values like red, white, black, right? It requires to store the single value. Okay, it requires to store the single value. So as a consequence, the smaller the memory is required here in this case. This is pretty simple. The hash encoding, it builds a dictionary basically. That's all, and then it stores the distinct values your text column, and for each value, right, each text value, the distinct value, right, distinct text value, it assigns the integer values for the index. This index value will be used to replace the original value in your data set. Next one is the run length encoding. So this is the one is used to look for repeating values. This is actually a pretty straightforward one because but it becomes really powerful when you combine the run length encoding with your dictionary encoding. Okay, now let us take a look at this data set, simple data set. You have a column called quarter, and here the Q1 repeats multiple times. How many number of occurrence of Q1s are the 310 times Q1 is repeating in this column, and the Q2 is repeating 290 times. In this case, simply put Q1 and Q2 in the table, and then Q1 start with the first record, and then till 310th record, the Q1 values are repeating it, start and count, okay? And the Q2 starts from 311th, place, right? 311th time, and it goes up to 219 times. This is what you run length encoding. In the case of run length encoding, by combining the dictionary encoding nothing but your hash encoding, right? So what it does is, look here, this Q1, Q2, Q3, 4, it takes the distinct value from this original column. It builds a dictionary. The dictionary, it assigns the unique integer value, sequential integer value for each distinct value, okay? This is where your dictionary encoding is done. And now what happens, the Q1, Q2, all the things will be replaced with 0, 1, 2, 3. Wherever Q1 is there, it gets replaced by 0. And Q1 will get, Q2 will get replaced by 1. Okay, that's what we say. So Q4, 4, 4. The next one is the run length encoding. So we already have the dictionary in place. Next one is the data rows. Here what happens? So, the Q1, how many number of times it occurs? 310. So 1, how many number? 2, 290. This is how it, builds the table in the case of repeated column. Lower the cardinality, does that mean more duplicates? It depends on the volume of the data. Yes, Kuja. Okay, you are correct. One way you are correct. Let's say in my case, I have 1 million records are there. But, in the quarter, let's assume that in the quarter, even if you have 5 years of data, right, the quarter column will have only 4, right? Each year you will have only 4. But even if you have 10 years or 5 years data, given data sets are available, but the quarter column will have only 4 unique values. So in that case, obviously you'll have more duplicate values will be the Q1, 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 Q2, Q3, Q3. So more difference. In that case, the unique values are less. In simple term, if you, for example, you have employee ID column, let's say in TCS, almost 6 lakh employees are there. The employee ID column, what is the cardinality? There is no duplicate, right? There is no duplicate. It's all unique value. Okay, it's all unique value. See, irrespective of the more duplicates, right? In the case of ID column, let's take 10 records. Let's say in your company, 10 employees are there. If you look at the employee ID column, there the cardinality is very high. That means number of unique values are very high. Only when the number of unique values are less, that is called your cardinality. Okay. So it is not exactly like, more duplicates. Yeah, lower maybe, right? Yes. Right. So, but this is the idea here. The number of unique values are less in your table, the column, whichever column that have less number of unique values, that is called your lower cardinality. You understood? Even if you have 10 records and then you have a quarter column, and the Q1, Q2, Q3 is repeating multiple times. But here, if you see unique value, only Q1, Q2, only 4 out of 10 records, only 4 are there. Whereas the employee ID column or the order ID column, if you see, it's all very unique. You cannot have duplicate values, right? So you will not have duplicate values. Hence, the cardinality is very high. So this is how the run length encoding technique works to compress the data, and then it loads the data in memory. Okay. To summarize, we discussed about the two types of engine, the formula engine and storage engine. In the interview, they'll ask you, can you explain the DAX engine? Okay. What are the internal mechanics, internal mechanics of, or inner workings of the DAX queries? There are two engines. One is the formula engine, storage engine. The formula engine interprets and evaluates the DAX query, and then the storage engine, what it does is it compresses the data and encodes the data. This is the one in the storage engine is the one compresses and encodes the data. And there are two types of storage engine. One is the XVelocity. Previously, it was called as a VertiPag, and other storage engine is direct query. So there are two engines, formula engine and storage engine. Within that storage engine itself, you have two types are there: XVelocity and direct query. XVelocity is for import, direct query is for your this is a direct query. Okay, it's a direct query. Okay. The VertiPag is nothing but the XVelocity is used for in-memory storage, whereas the direct query is direct connections to external source. Both create so in that case, right, it create data caches, or in the case of direct query, it sends the query directly to your SQL server, and then the query returns the value back to your formula engine directly. Okay. And it stores the data using columnar database setup. So replace the VertiPag by XVelocity. Previously, it was called as a VertiPag. Now it is called as XVelocity. XVelocity stores the data using columnar data. Like I said earlier, the data is stored in separate column. Okay, so each column is stored separately. Okay, hence it can be accessed quickly. Next one is the raw data is compressed and encoded to optimize processing. Okay, the data can be compressed using value encoding, hash encoding, or run length encoding. So the overall compression of a column is determined by 4 factors. What are the factors? One is the cardinality and the number of repeated values, the row count, and the data type. If it is an integer type, value encoding. Text data type, hash encoding. If it is a repeated values, then it uses the run length encoding. The run length encoding, it combines both the dictionary, and then it builds a dictionary as well as the orally, right? Run length encoding table. It does the encoding for the repeated values.